Good morning students, 11th standard physics. We are continue our lesson kinematics part 2. In this video discuss about elements of vector algebra, elementary concept of vector algebra. Last class we have studied motion. A study of motion will involve the introduction of variety of physical quantity. You know physical quantity can be differentiated into two categories or two properties, scalar properties and vector properties. Both are very important in this lesson, scalar and vector. Vector is must. Are you clear children? Okay. The first property, scalar. Scalar property which can be described only by magnitude. Now listen to it. Only by magnitude. Magnitude means it is denoted by a number and a unit. Number is nothing but value. Value with unit. Say for example 10 meter. 10 is a magnitude number. Meter m. So in physics a number of quantities can be described by scalars. Say for example distance, mass, temperature, speed and energy. Now example of mass. A mom is tell us to get 4 kilogram of sugar. Now here magnitude 4 kilogram. So you will go to shopkeeper and ask for certain quantity of sugar. Shopkeeper will understand. He give the certain quantity of sugar. This is an example. One more example, temperature. What is the normal temperature of body? It is enough that if you say the numerical value 98.4 degree Fahrenheit, direction not necessary. So scalar quantity it has only magnitude. So students we call it as scalar. Okay. Then go to second property, vector properties, which is described by both magnitude and direction. Both magnitude and direction. So, say for example force, velocity, displacement, acceleration, momentum, so etc. In physics, certain quantity can be described only by vectors. I say simple example, velocity of bus 40 km per hour. The bus in the direction of east. So here 40 km per hour, that is magnitude. The direction, east direction, that is a direction of east. So it is a vector. Force, acceleration also vector. Okay. Then how to understand representation of vector? How to understand representation of vectors? Vector diagram represent a vector by these uses of an arrow drawn to scale in specific direction. An example of scaled vector diagram. Now listen to it. This is the arrow of the line. Length of line we call it is magnitude. Length of line we call it is magnitude. And arrow, that is a head part. Arrow is represented as direction. So students, this is the tail of vector. This is a head of vector. So magnitude and direction both are include. So student, in this above case the diagram shows that the magnitude is 2 Newton and the direction is along x-axis. The length of the line, this is the length of the line, gives the magnitude and arrow head. gives the direction. The vector is denoted in bold face letter such as A with an arrow above the letter as A vector. Read as vector A or A vector. Are you clear, children? Okay. Then if you want a representation of magnitude of vector, the length of vector is called the magnitude of vector. It is always a positive quantity. Sometimes the magnitude of a vector is also called a norm of the vector. For a vector, A vector. So students, you will represent these two lines. These two lines, read it as modulus of A vector. Can be also written as A. Both are same. So this is a magnitude of vector. Next topic, different types of vectors. Now first type of vectors, equal vectors. If two vectors A vector and B vector are said to be equal when they have equal magnitude and same direction and represent same physical quantities. Now see the diagram. Two vectors are said to be equal if they have the same magnitude and same direction. A and B, same magnitude, same direction. Wherever be their initial position. Vector A vector and B vector have the same magnitude and direction. Therefore, A and B are equal vector. Are you clear, children? Okay. Then next type of vector, collinear vectors. Collinear vectors are those which act along the same line. Their angle between them can be 0 degree to 180 degrees. 0 degree or 180 degrees. So, the type of collinear vectors, parallel vectors. First one is parallel vector. Sometimes say about like vector. If two vector A vector and B vector act in the same direction along the same line or on parallel line, then the angle between them is 0 degree. Now, like vectors. If two vectors are said to be like, if they have same direction but different magnitude. Now see the diagram, red and blue line. Both are same direction but different magnitude. This is a like vector. Unlike vector. Then go to second type of collinear vector, unlike vector or antiparallel vector. If two vector A vector and B vector are said to be antiparallel when they are in opposite in direction along the same line or on parallel line, the angle between 180 degrees. Now listen, unlike vector, this is a vector and B vector. Both are different magnitude, opposite in direction. Different magnitude, opposite in direction. So this is a unlike vector. And one more vector, opposite vector. The vector of same magnitude but opposite in direction. This is a opposite vectors. Okay, next one, very important one, unit vector. It is a very important. Sometimes ask 2 mark question. So this formula is very important. A vector divided by its magnitude is a unit vector. The unit vector for A vector is denoted by A unit vector or A cap. It has a magnitude equal to unity. Unity means 1. Now listen, a vector having unit magnitude is called a unit vector. It is also defined as the vector divided by A vector divided by own its magnitude A. A unit vector in the direction of vector A vector written as A cab. A cab. Okay. Okay. This is a formula of unit vector. We can write A vector is equal to A into A cab. Thus we can say that the unit vector specifies the direction of the vector quantities. So students, vector can be written as the product of magnitude and unit vector along its direction. Next type of vector, orthogonal unit vector. Orthogonal means mutually perpendicular each other. Let's I cap, j cap and k cap be three unit vector which specify the directions Now see, along positive x-axis, positive y-axis and positive z-axis. These three unit vectors are directed perpendicular to each other. The angle between any two of them 90 degrees. So students, I unit vector, j unit vector and k unit vector are example of orthogonal vectors. Two vectors which are perpendicular to each other are called orthogonal vectors. Now see the diagram. This is a orthogonal unit vector. Three axes are mutually perpendicular each other. So this is a orthogonal unit vector of diagrams. X-axis I unit vector, j unit vector along y-axis, k unit vector along z-axis. These are three most common unit vector in the positive direction x, y and z axis of Cartesian coordinate system. So denoted by I, j, k. Since they are along the mutually perpendicular direction, this is the angle 90 degree. This angle also 90 degree. This angle also 90 degree. They are called orthogonal unit vector. And two more vectors, null vector or zero vector. Zero vector, a vector whose magnitude is 0. Vector whose magnitude is 0. This is called zero vector. Proper vector. All the non-zero vector is called proper vector. Clear children? Next topic, addition of vector. Already you know that as vector have both magnitude and direction, they cannot be added by the method of ordinary algebra. Thus vector can be added geometrically or graphically. We shall now discuss the addition of two vectors graphically using a two-tile method. Now listen to it. Consider two vectors A vector and B vector which are acting along the same line. To add these two vectors, join the tile of B vector with the head of A vector. This is a head of, this one is a tile. The resultant of A vector and B vector is R vector, that is equal to A vector plus B vector. The length of the line AD gives the magnitude of resultant vector R vector. R vector acts in the same direction as that of A vector and B vector. In order to find the sum of the two vectors which are inclined to each other, triangle of vector or parallelogram vectors can be used. Then go to discuss triangle of vectors. Students, next go to discuss about, it is a very important topic, triangular law of addition method. Listen very carefully. statement of triangular law of addition. If two vectors are represented in magnitude and direction by the two adjacent sides of the triangle taken in order, then the resultant is the closing side of the triangle taken in the reverse order. So student, let us consider two vector, A vector and B vector. This is a vector, both magnitude and direction. Length of the line we represent as magnitude, arrow is represented as direction. So this is the head of the A vector, this is the tail of the A vector. And another vector B vector, this is the head of the B vector, this is the tail of the B vector. So students, to find the resultant of two vector A vector and B vector which are acting at an angle theta, the following procedure is adopted. Now the first draw OA. First you draw OA is equal to A vector. Then starting from the arrow head of the A vector, draw the vector AB is equal to B vector. Finally draw a vector OB. Is equal to resultant vector R vector from the tail of the vector A. This is the tail of the vector A to head of the vector B. Are you clear, children? Head of the vector B, vector OB, this is a OB, is equal to R vector. Is a sum of the vector A vector and B vector. Thus R vector is equal to A vector plus B vector. Are you clear, children? This is a important one. The resultant vector R vector is equal to A vector plus B vector. To find the magnitude of resultant vector and direction of resultant vector, the magnitude and angle of the resultant vector are determined from the diagram. Consider the triangle ABN, which is obtained by extending the side OA to ON. Now listen, student. The right angle triangle ABN. The right angle triangle ABN. Now calculate angle theta, sin theta and cos theta. What is the formula for sin theta? Sin theta is equal to opposite by hypotenuse. What is the opposite? BN. BN divided by what is the hypotenuse? B vector. Now only we are calculated magnitude. So simply write it B. Therefore BN is equal to B sin theta. And next calculate cos theta. What is the formula for cos theta? Adjacent side and divided by hypotenuse. What is the adjacent side? AN. AN divided by hypotenuse B. Therefore AN is equal to B cos theta. Understand, student? Okay. For angle, right angle triangle OBN, we can take angle right angle triangle OBN. We have using Pythagoras relation. What is the Pythagoras relation? OB square, that is a formula. OB square is equal to ON square plus BN square. Are you clear? Okay. What is the distance OB? OB distance R vector. Now only magnitude. Therefore r square that is equal to ON. What is ON? A plus AN. What is the value of AN? B cos theta. Therefore A plus B cos theta whole square plus Bn. What is the Bn? B sin theta. Therefore B square sin square theta. Are you clear, children? Now using trigonometry relation, A plus B whole square, r square that is equal to A square plus B square cos square theta plus 2AB cos theta and plus B square sin square theta. Now A square plus B square. B square is common. Write it outside the bracket. Cos square theta plus sin square theta. And a plus 2AB cos theta. Now tell me what is the value of cos square theta plus sin square theta? That value 1. A square plus B square plus 2AB cos theta, that is equal to r square. Therefore the magnitude of resultant vector r is equal to square root of A square plus B square plus 2AB cos theta. Are you clear, children? This is the magnitude of resultant vector r is equal to square root of A square plus B square plus 2AB cos theta. To find the direction of resultant vector, if theta is the angle between A vector and B vector, now see the diagram. This is the A vector, this is the B vector, that an angle theta. Therefore magnitude of resultant vector r is equal to modulus of A vector plus B vector, that is equal to square root of A square plus B square plus 2AB cos theta. This is the magnitude of resultant vector. Now if r vector make an angle alpha with A vector, now tell me the angle of r vector and B vector, that is alpha. So the right angle triangle OBN, alpha, we can calculate alpha is nothing but tan alpha. Tan alpha is equal to opposite. What is opposite of BN? Alpha ke opposite BN, adjacent divided by ON. Therefore BN divided by OA plus AN. Now substitute the value of BN. B sin theta already find out, divided by OA at a distance A plus AN distance B cos theta. B cos theta. Therefore tan alpha is equal to B sin theta divided by A plus B cos theta. And finally write it angle alpha is equal to tan inverse of B sin theta divided by A plus B cos theta. This value of direction of resultant vector. Topic: second addition of vector. Second type of addition of vector, parallelogram law of vectors. Parallelogram law of vector. Now see the statement. It is a very important one. Now understand, students, if two vectors acting at a point are represented in magnitude and direction by two adjacent sides of parallelogram, then the resultant is represented in magnitude and direction by the diagonal passing through the common tile of the two vectors. This is your statement. So you can understand and see your diagram. Now I tell you simple way. Listen it. Let us consider A vector and B vector. Let us consider two vector, A vector and B vector, which are inclined to each other at an angle theta. At an angle theta, let the vector A vector and B vector be represented in magnitude and direction. Represented magnitude and direction by the two sides of OA and OB of a parallelogram OACB. This is a parallelogram vector. The diagonal OC passing through the common tile of O. This is a common tile of O. Gives the magnitude and direction of the resultant vector. R vector is equal to A vector plus B vector. Are you clear, children? Okay. Now calculate magnitude of parallelogram vector and direction of parallelogram vector. First of all, magnitude. We can calculate magnitude. Now listen. Cn is drawn perpendicular to the extended OA from C. The angle CON made by resultant vector with A vector B an angle beta. Now then ONC is the right angle triangle. We can write Pythagoras equation. What is Pythagoras equation? R square, that is a hypotenuse. R square is equal to ON square plus CN square. What is the value of ON? OA plus AN. OA plus AN whole square. Now the value of OA, that is a magnitude value A. Only is represented A, and AN value B cos theta, CN value B sin theta. Okay, now write it. This is a Pythagoras relation. R square is equal to ON square plus CN square. Now substitute the value OA plus AN square, AN whole square plus CN square. Now substitute OA value A plus AN B cos theta. So whole square plus B square sin square theta. Now substitute trigonometry relation A plus B cos theta whole square and substitute and get the answer. R square is equal to A square plus B square plus 2AB cos theta. Now we can write it magnitude form. R is equal to modulus of A vector plus B vector, that is equal to square root of A square plus B square plus 2AB cos theta. Are you clear, children? Okay. Now here some case is there. Case 1, when theta is equal to 0 degree. Now substitute this relation. Magnitude of vectors R is equal to modulus of A vector plus B vector is nothing but A plus B. So student, that is equal to square root of A square plus B square plus 2AB cos theta. Now substitute theta value cos 0. What is the value of cos 0? That is equal to 1. So and after get result square root of A square plus B square plus 2AB. So what is the trigonometry relation A square plus B square plus 2AB? That is A plus B whole square. Now square root term, that is cancel, and get answer. R is equal to A plus B. R is equal to A plus B. So next second case, when theta is equal to 180 degrees. The same way substitute cos 180, that is equal to minus 1. So minus 2AB. A square plus B square minus 2AB that is trigonometry relation a minus b whole square, and after get answer r is equal to a minus b. Are you clear, children? Okay. Then third case, when theta is equal to 90 degree. Now substitute cos 90. What is the value of cos 90? 0. So total term is 0, and I get answer square root of a square plus b square. So this is a special case of magnitude of parallelogram vector. Okay. Then direction of parallelogram vector. Now let angle beta be the angle between vector a vector and r vector. A vector and r vector. So okay. Now see the diagram. Once see the diagram. Listen to it. This is the resultant vector r vector. This is the magnitude of a vector. That is the angle beta. So beta is equal to opposite term b sin theta, adjacent sign a plus b cos theta. So now write it. Equation tan beta is equal to Cn by On is equal to b sin theta divided by a plus cos theta. Now listen student, triangle of vector result and parallelogram vector result both are same. Magnitude value also same, direction value also same. So students, so try to understand. Okay students, our next topic, subtraction of vectors. Since vectors have both magnitude and direction, two vectors cannot be subtracted from each other by the method of ordinary algebra. So student, this subtraction can be done either geometrically or analytically. We shall now discuss subtraction of two vectors geometrically using. Now listen it. If you take an two vector, that is nothing but two non-zero vector. One is a vector, this is the a vector, and another one is b vector. Both are along positive direction. This is the positive x direction, b vector positive y direction, which are inclined to each other. The angle between a vector and b vector, this is the angle theta. Are you clear, children? Okay. Now the resultant of two vector a vector and b vector. What is the resultant of two vector? Both are positive direction. So resultant of two vector r vector is equal to a vector plus b vector. This is the resultant of two vector a vector and b vector. Now simply draw the parallelogram law of vector. Okay. Now come to the point. The difference a vector minus b vector, this is along positive direction. In opposite in direction, negative y direction. This is nothing but minus b vector. This is nothing but minus b vector. Now calculate the angle between a vector of positive direction, b vector of negative direction. What is the angle? So already you know that this is a total angle 180 degree. So 180 minus theta. 180 minus theta. This angle between 180 minus theta. Which one is a vector minus b vector? This is the angle. Okay, now calculate resultant of two vector a vector and minus b vector. What is the resultant of two vector? This is the resultant of two vector. Now draw the parallelogram vector. So now calculate resultant of vector a vector and minus b vector. Therefore r vector, that is equal to a vector is positive direction minus b vector. Now we can write this equation. R vector is equal to A vector plus of minus B vector. Are you clear, children? Okay. Now we can find the resultant of magnitude vector or magnitude of resultant vector. Calculate A vector minus B vector, that is equal to A vector plus minus B vector plus of minus B vector. So students, already you know that triangle of magnitude vectors. Now see, this is a triangle of magnitude of addition vector. R is equal to modulus of A vector plus B vector, that is equal to square root of A square plus B square plus 2AB cos theta. Now this relation can be using subtraction of vector. So therefore R is equal to modulus of A vector minus B vector, that is equal to square root of A square plus B square plus 2AB cos 180 minus theta. Now listen to it. So this is an angle. This is an angle between subtraction of vector A vector minus B vector. So 180 minus theta. Now substitute here, and a mathematical trigonometry relation cos 180 minus theta, that values minus cos theta. Are you clear, children? Okay. Now write it. Modulus of A vector minus B vector, that is equal to square root of A square plus B square. Now substitute cos 180 minus theta, that is equal to minus cos theta minus 2AB cos theta. So this is the magnitude of subtraction of two vectors. Are you clear? Okay. Then calculate direction of subtraction of two vector. Already you know the direction of triangular vector. Tan alpha is equal to B sin theta divided by AB cos theta. So now using angle, this angle, the positive direction of angle alpha 1, negative direction of angle alpha 2. Now we can calculate negative direction of angle alpha 2. Therefore now direction of subtraction of two vector tan alpha 2, that is equal to, what is the formula? B sin theta of 180 minus sin 180 minus theta divided by A plus B cos 180 degree minus theta. There is a 180 degree. Okay. But now using trigonometry relation, what is sin 180 minus 180 degree minus theta? That is nothing but sin theta. Now here write it, sin 180 degree minus theta, that is equal to trigonometry relation sin theta. This is a sin theta. Now substitute here. Therefore tan alpha 2, that is equal to B sin theta divided by A plus B cos theta. Already you know that cos 180 minus theta, that is equal to minus cos theta. Now negative sign are indicated. So therefore tan alpha 2 is equal to B sin theta divided by A minus B cos theta. Thus the difference A vector minus B vector is a vector with magnitude and direction given by the equation. Both are same but opposite in direction. So student, this is the direction of subtraction of two vectors. Discuss about components of a vectors. In the Cartesian coordinate system, any vector can be resolving into three components along x component, y component and z component. First of all, we discuss two-dimensional component vector. rectangular component of two dimension vectors. Now see, we can take out two component of x component and y component. X component and y component. So two dimensional Cartesian coordinate system, the vector A vector is given by A vector is equal to Ax I unit vector plus Ay j unit vector. A vector make an angle theta with the x-axis and Ax and Ax and Ay. The component of A vector along x-axis and y-axis is respectively. Then calculate theta. Sin theta is equal to opposite Ay divided by hypotenuse A. Now the value of Ay is equal to A sin theta. And also cos theta, Ax divided by A. The value of Ax is equal to A cos theta. Are you clear? Okay, this is a magnitude of the vector A vector. So now write the magnitude of A vector. A is equal to square root of Ax square plus Ay square. This is the magnitude of component vector, two dimension component vector. And calculate direction of two dimension component vector. Now see, this is the angle theta, opposite by adjacent side, that is tan theta is equal to Ay, opposite of Ay and adjacent Ax. So we can take a theta value. Theta is equal to tan inverse of Ay divided by Ax. Okay, understand students? Okay, then three dimensional component vector. This is a three-dimensional component vector. Consider the three-dimensional coordinate system. With respect to this, a vector can be written in the component form. A vector is equal to Ax I unit vector plus Ay j unit vector plus Az k unit vector. Are you clear? Okay. Ax is the x component. Ay is the y component. Az is the z component. With respect to A vector. Are you clear? Okay. Then last one, vector addition using components. Two vectors A vector and B vector in a Cartesian coordinate system can be expressed as. So students, in the previous section we have learned about addition and subtraction of two vectors using analytical method or geometrical method. But once we choose the coordinate system, the addition and subtraction of vector become much easier to calculate the values. So two vectors A vector and B vector using Cartesian coordinate system. Okay, now listen, this is a three-dimensional Cartesian coordinate x, y, z. X-axis, it is a vector with respect to A vector. This is a Ax along x component, Ay along z component, Az along z component with respect to A vector. So students, now two vector is given. One is a vector, as I represent A vector. Therefore A vector is equal to Ax I unit vector along x-axis plus Ay j unit vector along y-axis. So plus Az along z-axis k unit vector. Az k unit vector. Are you clear? So second coordinate system B vector with respect to B vector. Now same time, as I represent B vector along x-axis, along y-axis, along z-axis. That is a x component Bx I unit vector, y component By j unit vector plus z component Bz k unit vector. Are you clear, children? Okay. Now then the addition of two vectors A vector plus B vector is equivalent to adding their corresponding x, y and z direction. Is nothing but components. So A vector plus B vector that is equal to ax plus bx into I unit vector common, that is a unit vector is common, I unit vector, j unit vector and k unit vector. Now write this plus ay plus by into j unit vector plus az plus bz into k unit vector. This is a addition of vector by using component, 3-dimensional component. Okay, next similarly the subtraction of two vectors is equal and to subtracting the corresponding x, y and z component. It is the same way, a vector minus b vector. So ax minus bx into I unit vector plus ay minus by into j unit vector along y component. This is the x component plus az minus bz into k unit vector along z component. So this is a vector, two vector of addition and subtraction. Students, hope you understood. Next go to discuss about evaluation. First question, define a scalar, give examples. Second one, define a vector, give examples. And third one, what is unit vector? It is very important 2 mark question, note it down. And fourth question, what are orthogonal unit vector? Fifth question, explain equal vector and collinear vector. And last question, explain in detail the triangle law of addition. It is very important 5 mark question. So students, if you have any doubt, note it off. We clarify after reopening school. Thank you.